Well, g'day, Max here again. Welcome back to the shop. So this is part 2 in our series of our banjo shaft for our change gears. So what we're going to do next is cut the 16mm thread, and we don't actually have to cut the thread to the full length. So I'll just take a quick check, make sure we're cutting the right pitch first. Just waiting for my number to come around, which is right here. So because we're cutting a metric thread on a lathe with an imperial lead screw, I do disengage at the end. Not all people do. It's just what I do. When I reverse the lathe, I make sure I re-engage on the same number on the threading dial when it comes back, and you won't go out of pitch then, providing your threading dial does not go one rotation and you re-engage, you'll be fine. So looking at this, we're cutting 2mm pitch thread and we're on it there, so we're safe to rock and roll. We're not doing a thread relief, we're just coming up and pull our tool out at the appropriate moment, and all will all be fine. So let's rock and roll. Also, we're not cutting to full depth either, as we'll cut to full depth after the heat treatment. A little bit of oil for the last couple of cuts. Right, we'll have a look at that. I think we might just go one more. So our nut shouldn't want to screw on, and it doesn't. That's exactly what we got. So we're about 3/4 thread depth there. So you can see how the last thread just there comes around and tapers off as we've pulled the tool out. Let's head for the milling machine and we'll put our spanner flats on. So this is our setup for these spanner flats that we've got to do, so we can get a spanner on our shaft to tighten it up. Dead easy, no indexing to do, as we have a perfectly capable milling machine with an X and Y axis, and that's how we'll get our square. Now remember the little step we turned on? So the little step is our spanner size. That's machined down to 12mm. So not only we don't have any indexing to worry about, we don't have any measuring to worry about too. As long as we don't eat into our shoulder, we'll be fine. Okay, fits beautiful. Spanner fits them nice. Quick and easy way to index and referencing your size off the little step turned on the end. And I mean, that can be machined off afterwards, or it can stay. I'm just going to leave it in this case, as it's nothing's going to happen. If I machine it off, then I've just got to reinstate the center there that we're going to use to support for grinding, so I'm just going to leave that be. So next stage, yeah, cross hole, which I'll do off camera, and then I think we'll head over to the new shop and we'll harden this thing over there. The other thing I'll point out too, because we've used steel that was originally an axle. Now, as far as I can gather from what I've seen, axles are induction hardened. Now, you can tell if a part's induction hardened, if it's still shiny and not all rusty, you'll see the ring around the end where the hardening's gone in is a good indicator. And induction hardened parts are quite often water quenched, so they'll have the heating coil go over the part, and then immediately behind that there'll be quenching jets of water. So it's quite possible this is a water quenching steel, and I have quenched it in oil, but I'm not big on water quenching unless the steel is specifically designed to be water quenched. What you can do is a thing that Dad told me to do back when he was still alive, was to put a thin layer of oil on top of the water, and what that will do is give the part a thin oil coating as it goes into the water, and it just knocks that suddenness out of the cooling. So just in comparison to our old shaft, so we have a 45 Rockwell file on our old shaft. You can see that's biting into that as well. So we'll go to our 40 on the old one. So the 40's skating off it, so it's the original part's between 40 and 45. So back to our one. And like, that's not actually, it's not skating off, but it's not biting in, wanting to bite in either. So, yeah, I think, well, as I said before, I think we're in a good part. I'd be too scared to want to get that any harder. If, say, for example, if we went through a rehardening, re-quench process, and inadvertently we get a crack form, something happens, and this snaps off while the machine's running. This is a far safer state to be in. We're only a little bit below the original hardness, so yeah. Right, here's our part. I have cleaned out the centres just by hand with a centre drill. Let's pop it in the chuck. If it's straight, we'll just hold it in the chuck. If it's got a bend in it or anything like that, any distortion from the heat treatment, and we'll have no option but to turn it between centres. That way, if we're turning it between centres and it's got a slight bend in it, we're averaging out the error or the bend between our two locations. If it's bent and you put it in the chuck, one end of your shaft's going to cop it all, so it's better to split the difference between two areas, especially if you're close, if you don't have much allowance left for finished machining. Let's have a look. That looks pretty darn good to me. Right, so we'll come in now and re-pick up on our thread. I'll just wait for me number one to still come around. I'll still use the same number. There it goes there. I think we've got it there first pass. We'll run back. Put on our new cut. Okay. Yeah, no, that's looking good. Wrong way, reverse. Okay, I'll just take a quick size check. Just need a bit more. Just a bit of oil for the last cut. Okay, we'll clean that off and have another test fit. That's it, we're there. Okay, I'll just run a file over that just to clean up any of the sharpness and a faster speed. Okay, I've had to dispense with the tailstock as I'm a bit banged up for room, so we'll see how it goes without the tailstock. Quite often I've got to take the belt guard off the tool post grinder to get clearance with the tailstock, or I'll put the grinder on an angle and dress the wheel accordingly, but we'll see how it goes. We've only got a little bit to take off, just under 0.2 mil. Before heat treatment we were right on 0.2 above 16, and we are now 0.02 below where we were before. So we've lost 0.02 in the hardening process. Sometimes that size doesn't change, and sometimes it can actually grow. So. One little thing I will do is put a little bit of tension on my cross slide lock. Doesn't need much, just a little bit. Okay. Little over 0.1 to go. Pretty good for parallel. There we go. Okay, 0.07 to go. Okay, that's where we need to be, 16mm. Lovely. I don't know how this camera will pick it up, but the grinder gave us a really nice finish. 40.05. 40.05. Not bad for a lathe that the headstock moves around. Stranger things have happened.